Hello everyone, welcome again to this other session here where we are going to cover Starknet smart contract. I believe if you have been following through, we have covered like a half of. Okay, yeah, I had some echo there. I had to take care of that. So I believe if you have been following through, we have covered some aspects of Starknet, starting from getting started with Starknet. That's like an introduction to Starknet, to setting up the environment and doing some Cairo code. So today we are taking that one further, and we are going to cover a few things in writing Cairo programs. That includes doing a simple program that can be a calculator, a shopping cart, and also we'll also introduce smart contracts. And today we are going to write our first smart contract and deploy it to Starknet and also interact with it. So bear with me for this lesson today. It might be a heavy one to take, but I'll try put things simple and straightforward for you to learn along. So without further ado, let's get started. So I'll present my screen. I believe it's on the way, so we give it a moment. Yeah. So this is what we're going to cover today, being another session. So that's smart contracts on Starknet, session 4. So what will we be covering in detail? So we have writing programs with Cairo, advanced Cairo programming. So that is writing some Cairo and doing some advanced stuff. Smart contracts on Starknet, doing some practical examples and exercises, step-by-step setup guides, and also some troubleshooting tips. So let's go to the next one. Here we have setting up the development environment. And if you do recall, we done this one on the second class. That's a deep dive. And today I'm just going to peruse through to make sure that we are together, because we have reached that point where we need now to get our hands dirty completely. So at first we said you need Rust, because the environment requires Rust to run. And also you need to set up VS Code with the two recommended extensions that includes Cairo 1.0 and Cairo syntax. And also after that, we have like this setup installation guide. Start by installing Rust, then setting up Starknet DevNet, Starknet Foundry, installing Scab, and setting up VS Code. That's what we covered in session 2. If you missed this, kindly refer to the other video. So I'm not going to go through this complete like installation steps. That's starting from installing Rust, installing DevNet, installing Scab, setting up VS Code, and also setting up VS Code. Yep. So the other class, the last class on Monday, we had covered basic syntax and data types. We had covered contract structures and functions. So today we are going to take this one further. We had not covered a few more other data types. So that includes arrays and structs, and also tuples, like in depth, and also structs with the traits, of course. So that's what we're going to start by today. And also after that, we'll get to writing our contracts. So this like the first portion, structs. So this how a structure looks like. So we do have structs in Rust. So if you have a background in Rust, you have something, or you do understand how this is. But if you don't have a background in another programming language, so a struct, you can take it as a structure, like a short form of structure, and it sort of helps you group things together. In languages like Python, we have things like classes. In JavaScript, we also do have classes that you can use to come up with these custom data types. So abstract can be a custom data type. For example, you can say abstract of a user, and hence from there you have like a user with a username, with a first name, last name, email, password, and all those things. So let's say you wanted to sort of track users in your contract, you will be using structs to achieve that. So you do struct user, then you say maybe address, the name, the email, and any other information, including balances or tokens, etc., or assets this user has. So we will be using structs to be able to cover or store data in our contract. And also for structs to work fully, they work hand in hand with just a moment. Yeah, so for structs to work fully, they work hand in hand with traits, and the traits are a sort of interfaces that can be used. Okay, we do implement interfaces to structs so that or traits to struct so that we can extend the overall functionality of a struct. This is like now extending the user object that we have created. So I'll show you that one in just a moment. We also did cover control structures. That includes loops and some conditions. And also we did cover functions. So you were able to see how a function looks like. And so today we are going to just go through everything while we will be writing our programs. So to get started, I'm just going to get back to my VS Code and also do some code. So just a moment, I set it up. I'm just going to do a new folder here and say session 4. And in session 4, I'm going to open the terminal and say scab new. And for our project here, we are going to call this project, I think I'll call it something like structures, like this. And once I have done created a new project, and if you do recall, well, we said whenever you are starting your, I'm trying to increase the, okay, okay. So whenever you start a new project, you need to use the command scab new project name. So scab new will start you a new Cairo project. It's like now setting up your environment for a Node.js project where we usually do like something to do with is it npm init? I think so. So yeah, npm init or Python where you set up your environment and all those. So for Starknet or for Cairo, you just do scab new structures. So for this case, it has created as a new project called structures. And if I go into the created project, so I'm going to open this in VS Code. And here we go. So I'll increase my font size a bit. I think that one's visible enough. Yeah. So here we have our project called structures. And I actually wanted to open it in the project itself to avoid lots and lots of issues. So I'm going to cd into the structures folder, then open the VS Code there. So here we have VS Code. And if you look on the left side, you'll notice we have an src folder and also .gitignore and a scab.toml file. Starting from top, bottom up, we have scab.toml file, and in the scab.toml file is where we do define like the name of our project, and in this case our project is called structures. And after that we have our dependencies. So for npm or node project, it will have been package.json, and under in there you will find your dependencies. And also here is where we'll be adding our dependencies. For example, here you might want to add dependencies like Alexandria. So somebody might be asking what Alexandria is. Alexandria is a math library on Cairo So if you have some math things that you want to do, Alexandria is your thing. So usually adding them like that might be quite difficult or cumbersome. So to help you achieve or add a new dependency like that, usually you use scab command again. So, or the scab tool. So if I come here and I say scab help, you'll be able to see it has given us some commands that we can use. For example, add dependencies to the scab.toml manifest file. And we have others including format, check. So there are a lot of commands here that are very critical for us to use. So every of these commands have its purpose. So just read through down and you'll be able to get everything up and running. And also we have something like run here. So run here helps you to run custom scripts. So for example, here we usually do something like, I think, scripts, then we just say maybe test, and we just say snforge test. So whenever you are trying to run such a command, you'll find yourself doing something quite easy. For example, scab run test. So this one is going to run the test command or the test script that we have in our scab.toml file, but that's a snforge test. Otherwise, you can just quickly just type it snforge test here. But sometimes these scripts are useful whenever you are doing like complex uh, commands on the CLI. So there are some complex commands that I'll show you uh, as we continue up. So I can get rid of my scripts here, and let's try to add Alexandria using the scab command. So clear scab add Alexandria. Okay, I need to specify, I think, for example, like that. So let me just try that one. So let's see what was, yeah. So we have Alexandria added, but it will fail to find it because we don't have like Alexandria 1.0, I think. Error trying to connect, lookup address, service not known, something like this. Okay, just a moment. I think I might have messed my machine a bit while doing. So sudo nano it's resolve.conf, enter my password, then I need to, oh okay, actually it's set up correctly. Where is it failing then? Okay, so let's continue. I think it's because we don't like have Alexandria 1.00, but that's how you could add dependencies to your project. So maybe even to your contract, actually to your contract. So we have seen what scab is and how to use it to manage different packages and to manage some other few things, including the scripts that I've talked about. Next, we have scab.log. This one just tracks the different packages you have, and also it has its own purpose. Then we have the .git ignore here. The .git ignore helps you to ignore files that you don't want to push to your GitHub account or to your remote Git uh, to your Git remote. So usually you add them all here. For example, maybe you might be having, since it's your contract, you might be having a file like documentation.md, but that you don't want to push. So usually you ignore it here to make sure you don't push things that are documentation.md that are unnecessary to your GitHub, or exposing things that are not good, including things like .env, all these things, or all these files and the folders. Usually this way you add them, just like ignoring them, so that they won't be pushed to GitHub. Next, we have these are two more folders that have come up. The first one is target folder. So whenever you do a build of your project, it's built into the target folder, and here you can find your Sierra file. As we said earlier, I think on the second class when we were covering things like When we were covering the topic on deep dive into Starknet, we talked about how Sierra compiler or how Cairo compiler works. So it just compiles your code down to Sierra. Then this Sierra program is also compiled down to Casim. At the end of the day, Casim is what is required for your smart contract, or Cairo. That's like what your the Cairo compiler will want to run your smart contracts somewhere. So this is the build process. So once it's built, this way it's stored. So you can access your Sierra file and your custom file from this specific directory. Next, we have our SRC folder, and SRC folder is the entry point of our project, or it will be the entry point of the smart contracts. So this way you do like everything, and usually it's either src lib.cairo or src main.cairo, but we have lib.cairo for Cairo specific, and the main entry function is main. But when we reach the contract level development, you'll realize main is not the entry point, but rather something else. So we'll cover also that one there. Next, we have a send foundry cache. So just to track cache of your Starknet foundry stuff, that includes a sendcast and a sendforge tools. So let's get started to what brought us here, and that includes okay. There is something else here that is mod tests. This is a module of test specific because it has already been decorated or attributed with a CFG test attribute. So this one shows that this specific module is for test. So whenever we'll be writing our tests, you have to sort of either create something like this or create a test folder and decorate each test by hash test uh, attribute. So that's how tests work in Cairo. So I'll get rid of this one. And also we have our setup function here, the Fibonacci function. So you can see here we have fn, the function name, any parameters into brackets. Then if there's a return type, we use the arrow, then the return type. Then we do our function body there. Then finally we do a return. Also, one thing to note here is that, like Rust, of course, if you want to return something, you can either return it like this, just on its own line. For example, here we are returning the value of A. Because it's a U.2, we just do A like that. Or another way to return is just if you add the semicolon at the end, then remember to do the return there. Otherwise, if you don't want to have the return and the semicolon, you just get rid of them and A will be returned. So that's how you return values from functions in Cairo. So you get rid of these two, and also so I'll move this one down a bit, close my sidebar, and we have now a better view of what we want to achieve or what we are writing today. So I said I'm going to introduce two things or a few more data types that includes structs, very critical in Starknet, and also we have tuples, very critical, and finally we have arrays, also very critical. So we covered the basic types that included integers, booleans, and the felts. So today we are also going to move further, cover, oh, I didn't mention dictionaries. So let me just write them down quickly. What we'll be covering here is, let me start down like this. I'll start with tuples and go next to dictionaries. So for those who are familiar with the dictionaries from Python and JavaScript objects, it's the same idea here. Then also we'll be covering arrays and also finally structs. So this one will be quite quick. So try to follow through. And if you didn't get something, then Cairo book is your best place to be. There you'll be able to find more information. And also you can come back to the video and try to see what you missed along. So starting with tuples. So for example, tuples are denoted like this. So I can have them like this, and So that's a tuple. A tuple usually we just use like these brackets around, then we destructure the values. So and here we have a tuple that's a felt 252 felt 252. Usually when you do write some contracts like this or programs like this, just make sure every line runs. This part of the troubleshooting that I talked about earlier when I introduced this session. So when you do something small, to avoid having like problems at the end of the day, make sure you have like run it and try to see what happens. Otherwise, if you fail to run it, then you'll notice, okay, you have written an entire program, then it has several errors. For example, in this case, it's saying we are trying to return a u that too, but literally we are returning nothing here. And at the same time, it's shouting here, type annotation is needed, failed to infer. So just make sure you run your programs as you go on to avoid getting yourself into problems after writing an entire program that fails everywhere. So I'm going to do that and also introduce types to my values here. So I'm going to do that. Still, I'm having issue here. An email file 252 name missing terminal colon. Okay, think I must have missed something there. I'll just quickly go through my notes here. Yeah, so the way I have passed in these values or these types, it's not the correct way. This I think these are the effects of writing some lots and lots of TypeScript. So here we have a felt 252. So this should be felt 252, and also this should be felt 252. Believe that's the thing. So here Dalma says we have an error again. That is like the same error. Yeah, felt 252. Prefixing 1 1 mismatch the type felt 252 cannot be. Yeah, so this is something that our team had mentioned earlier. You might get yourself into this big issue of using double quotes and single quotes. And if you don't, like, make sure that you don't have like those double quotes in your program, then you'll be good to go. Otherwise, you have seen it almost got me down. So whenever you define them or define file 252s, make sure you only infer them using uh, single quotes. I believe the double quotes is good for byte arrays. Let's see, let username equals, I love my username here. Let's see whether this one complains. And yeah, it will complain, of course. So because it will be inferred as a file 252 by default. So let's see whether a byte array will also shout the same. So byte array can't shout because byte array now are like the normal strings. But even if you are using just a file 252s, make sure you use single quotes. But if it's a byte array, then you can use double quotes. Believe that one is clear. So don't get yourself into the same problem I have gotten myself. Then after this, I can proceed to sort of print out the result. And here I'm going to say something like my name is, then I pass in the curly braces. So the curly braces are like placeholders. And my name is that, my username is, I also pass in the username like that, and my email is that. Then after you have done those like placeholders, make sure you pass an equal number of values after the comma in your print line. So just make sure you pass in here, for example, name, username, and email, like that. Then let's see how it runs off. So you realize here it prints my name is some value, my username is Dalmasonto, and my email is that. So what are these values here? Why didn't it print it like them normally as it could have done with the username? So whenever you do your types, more so the file 252s, the integers and other okay, the file 252s integers except the booleans, you realize like it converts them to either an hexadecimal, or if it's not an hexadecimal, you might find it in big int format. So for example, here my name is converted to a big int, so you can't really tell what really happened, but byte array remains as it is because it's taken in as a string. So if I copy this value 75 for my name, then I walk into, so I'll just pull in the browser here and I go to, I think it's rapid, okay, yeah, rapid tables, and let's see what happens when we try to convert it back. So I think I'm converting from a decimal to a text, and then I pass in the value, then hit convert. I have the same value. Okay, it might be an hexadecimal. Convert, that can't be 0x. So I don't really know what this is. This kind of new then, but let's see what we have. I can take this decimal here, no, decimal to, yeah, to text. Then it's not converting it to anywhere. It's it binary. I need to convert this from here to a hexadecimal. Okay, let's just go from decimal to hexadecimal. Pass in our number. We have our hexadecimal here. Then we go from hexadecimal to text. Yeah. So it gives us like a big number that you'll need to convert to a hexadecimal, then from a hexadecimal to text. So this part of the security features just built into Starknet by default, or Cairo by default, making it one of the powerful layer 2s to Ethereum in terms of pushing for security besides scalability. So we have our name here written out as a big int, convert that one to hexadecimal. Yeah, that's where you need to use the right type for the right thing. So for this case, if you want a name that's a name like Dalmasonto, then make sure you save it as a byte array. But if you are in for hiding or just hiding that information, but remember this information will be still visible in explorers like StackScan and Voyager, not that you can totally hide it. But for those, for just somebody just want to read your information, maybe they'll just hit those hexadecimals, big ints, and they'll just sort of move on, exit. So that's how tuples work. So you can define your tuple like this, then destructure it like this, and also remember to pass your types there after the value. So if we have like two variables here, then make sure you pass in the two types in front of here. Then next we have, so these were tuples. Next we have the dictionaries. So what are the dictionaries? In JavaScript, we have objects. So we usually just do like this. And so this is what we usually do in JavaScript. But in Cairo, how do we do it? So in Cairo, you just need to say maybe let users of type felt 252 dict equals to default. Then you just initialize this one default. I believe that's how it goes. I have this one failing. Structure, okay, what's the error? It's saying, okay, that's a warning. Type annotation needed. Failed to infer from this. Failed 252 dict, failed to infer. So for our dictionaries, whenever you initialize your dictionary like this, fail to dict, and also it has given us the error here, type annotation needed. So whenever you hit an error like this, you can check available online resources or through the error on the terminal, try to find the exact problem. And in this case, it's saying type annotations are required. So for this case, I'm going to just pass in the type for this exact failed 252 dict. It's a failed 252 dictionary. Like the key should be a failed 252, but the value can be an integer or a boolean. So then to initialize it, you have to do like this. Once you have done like that, then you are going to pass in some values into the dictionary where you do insert the values to this given dictionary. So just do users.insert, and what I'm going to insert here, the key should be something like a username, and the value can be dalmasonto. So that is an insertion. To read the value, you can read it using the get method, or you can also use values. So something like users dot, I think get should give us the value. Due to previous error, and the problem we have here, ref argument must be mutable. So we have this here, but this one is not mutable, so we need to do like mute, let mute users so that it can be able to be changed, and have users.insert the value that we want to insert. If there are any questions, please do drop them uh, in the chat so that we can cover them as we go on. Otherwise, if we keep remaining silent, then we might miss something. I don't know whether there are any. Doesn't this single quote variable has max of that one characters? Samuel Munda. Yeah, you are right. So a failed 252 a failed 252 data type is only limited to that one characters, in fact, and hence that's what Samuel has uh, quoted here, saying doesn't the single quote variable has a max of that one. It's not the single quote variable, but rather the fail 252 that's only limited to 31 characters. Anything larger than 31 characters will fail to work. So that's where the term byte or the data type byte array comes in. So use byte array to store, I think, longer variables of this kind of strings as compared to fail 252. Thank you, Samuel. Yeah, so use the users.get method so that you can be able to get a given value that you inserted into the dictionary. So I'm going to just run this, confirm whether it's running. So this is the procedure of writing code. Don't just write code then run at the end. Run after each line, more so when you are new to it. I guess a dictionary keys are FL252 by default. Yes, they are. Yes, they are FL252 by default. So we have users.get. So let my username, and also here I'm going to use snake case to read the variable or to define my variables. Though some like using things like that one, camel case. So camel case will fail to work, or it will just warn you like it has done to me here. So Cairo by default, like Rust, only takes or wants you to write in snake case. So that's snake case, my underscore username. So if I do that and then try to print out print line, my username is, so if I have this like this, then pass in my username here. So this is what I'm going to get. Okay, I think I need to run this correctly. So that's what I'll get. So it will also print out my username like that. So that's how you pass in values to dictionaries and read them off. So use .get, and there are other methods on the dictionary. I'll only refer you to the Cairo book. Go learn more about those other methods. And next we have arrays. So arrays are critical for those of us who like doing list things. So for the Python guys, doing lists; for JavaScript guys, doing arrays; and also for the rest of the guys, I believe it's arrays and allocation, memory allocation stuff. So how do arrays work? So let's say I think I'll call this one nums equals to something like so you can't just immediately start writing an array like that, because that's the common thing that we usually do. This is what we usually do in other languages, but if you just do like that, automatically it will just fail, because number one, it does not have like, it doesn't know the types, it does not know you have, it doesn't have anything to do with the, okay, you can see here it's saying variable not dropped, etc., and other things. So to avoid such a thing, whenever you are initializing arrays, first give your variable a type. So for this case, I'm going to say it's an array of U8. And also after that, I'm going to initialize my array using the array macro. This is one way of initializing arrays in Cairo. So you can use the array macro to initialize the arrays, and you can see it has just worked fine, no errors. And also you can read the values by using several methods that are available on the array struct, such as we have at.get index. So you can use indexing to read all these values. For example, let's read the value of the first element, and here we are going to use this indexing stuff. So I will just do nums index 0 like that. So you'll be able to read all those using the normal some methods on the array struct. So to get more or learn more about those, we have this is the normal indexing. You can also use the .get method. I believe you can do .get and get at index 0. It does not have format, so once you do this, I think you need to do more other things like unboxing and unwrapping. So also we have another method called .at. Also, it will return something like a box trait that you will need to unbox, then unwrap. So all these things, they're available on the Cairo book. I'm only just brushing through. And then finally, we have structs. So this one, I'm going to return it to the normal way it is, like that. So for the structs, as I said, these are like classes, so you'll need to sort of define your struct somewhere. So I'm going to define it outside the main function, and I'm going to say something like struct user. I'm here. I'm using so I'm starting with my struct with an uppercase. Remember to do that, or use camel case whenever you are writing your structs, because they are sort of like a type on their own. They cannot just shout out there like doing when you are writing please will you touch on ownership today. So okay, let me then close on structs, then go back to ownership. I believe that one will inform what I'm going to do. So I'll just finish on structs, then roll back to ownership, and that one will sort of flow as I have it planned out. As I have it planned out. Okay. So whenever you are doing your struct, you can do struct user, and here you are going to say maybe now here I'm going to pass in a name, and I'm going to use the beta array, and after that I'm going to do my comma there, I think some sort of malaria is just behind me or something of that sort. I don't know. So once you do your name, next you are going to do something like email, and also you give it a type. Maybe give it some age, give it a type. Maybe are you 8 or are you 16? But I don't think if somebody, unless it's an age or something else, 8 is good. Uh, so that's how you pass in the values of or the properties of a given struct. Then once you have done that, you are going to initialize your struct down here. So here I'm going to do like let user1 equals to user. And usually whenever you do this, remember to pass in all the properties as they have been given from top down. Here we used byte arrays. I'm going to add also my email here. So email, and here I'm going to use a felt 252. So the reason as to why I've added email and decided it to be a file 252 just to iterate on the single quote, double quote thing. So remember that's how it flows down. Then after that, the name should be maybe passing the name. And after that, we had I had email here. So I'll just get rid of this one and have, okay, I can have username here then. Byte array. And then I have email name, and also I'll do username, and here I'm going to just do maybe that one. And after that, I'm going to do, after the username, we had the age, passing the age, and that's how it flows. So we have all that set. Then let's just run our program and see whether it works. So you do realize it just starts shouting variable not dropped. What haven't we done here? So whenever you do your structs, remember to pass or give it some attributes. For now, we are going to use a single attribute that is called, so we are just going to derive one attribute here using the derive attributes there. And here we are only going to use like the drop attribute for now, all of these attributes as it is. When we'll reach smart contract, we'll also cover further down, that is adding more of these attributes to make sure our struct is more powerful to be even stored in the contract itself. So that's how you do initialize your user. So if I do run this program again, now I have it working correctly, and now I'm going to do just print out some variables from this specific user. This is I'm going to do like a print line. This user's age is, and I'm going to just do like that, and then user1 dot age, like that. So if I do run this one, it will print out my age. There we have this user's age is that one. So that's how you initialize structs. But there's something more to these structs than just as they are like this, because the same structs can help you improve the functionality of your program. So for example, in this case, we don't just want to say user1.age, but we just want to get the user's information in just a single line. How can we achieve that? You can do something like the user's age is, the user's email is, all those things, while you just do here user1 dot something like email, etc. But we don't want really to do like this. So I'll walk right into traits. We'll get back to ownership after cleaning the traits so that I don't mix up the flow. So here I'm going to introduce another thing called trait, and the traits are a sort of interfaces for okay, for Python and JavaScript. Usually you can just immediately do your class user and immediately write your functions therein. And also there are interfaces. Okay, and same for JavaScript. You just do your class, then write the rest of the methods. But of course, they're extensible. Same with the traits and the structs. So you can have different traits to the same struct. For example, here I'm going to do user trait. And in this case, this user trait will only be implemented on the user struct, and that's how you do your trait. And here I'm going to write the first method, for example, print information. And this one is going to take in a snapshot to self. And also, actually, that's not how snapshots are written. I think I'm going too quick. So here I'm going to do self, and here I'm going to do at something like user, like that, I believe. Yep. Let's see what we get. And after that, it's just a method. So that's how you do a trait. You just like provide a blueprint of a given, or a blueprint of given functions. So if I may go back to my slides here, so I'll just quickly present them to illustrate a symbol trait that most of us are familiar with. Um, we have dealt or written contracts in different languages, and here we have an example of a given trait. So this trait is an interface, or is a trait for ERC20 contract. So an ERC20 contract, we know it has functions like name, or get name, get symbol, get Desmos, and other functions like allowance, approve, all those, transfer from, and transfer. So we usually write these traits, or these interfaces, these blueprints of what we want to do with our contract. Then after that, we go down to implement them. So I'm going to go back here to my function, or to my code, and proceed with the implementation. So here I'm going to implement this user trait. So I'm going to do in IMBPL in BL, and the thing I'm going to implement here is the user trait, and I'm going to give it a name, of course. After doing implement user trait in BL, this kind of to, so I need also to pass in the user trait here. So this is how it's sort of written. And then I'm going to implement it on the user struct, I believe. Then here I'm going to write the complete process, or the complete logic of this given function. So I'm going to just paste my function there. And here I'm going to say print line. So print line is a macro that you will need to do that. Then I'm going to do something like this. And here I'm just going to type in this as they are, but there's even a better way of getting these things close together. There's another macro called format. So I'm just going to say let user fmt equals to, I'm just going to format like that. And here I'm going to format all the information into this string. So this is an advancement in Cairo. Before, nothing like this was there, so things were sort of tough a little bit, but not that heavy. So I'm going to format all the information into this, then I'm going to print it down here as a single print. So that's another thing that I've introduced you can use in your contract while you're doing your things. So though I'm not fully sure whether format is for contracts, but I believe it is implemented with the latest Cairo version. That's 0.132, I believe. Here you can do now self dot, and here we know we have dot email. So let's just format this correctly. So my name is self, or not like that. My actually this is not the right way of doing it. let's just do it as straight as they are. So name, email, then what next? Name, email, we have username, and finally we have age. Then here I'm going to just pass in the values self dot name, self dot email, self dot username, and finally self dot age. So I think can I break this into two different lines? Let me hope so. So you might be finding yourself in a state that I am, that is like your Cairo is not working, like the VS Code extension is not working. You might need to restart your VS Code at some point, or uh, so that's what we have so far. So I have done the implementation, but we haven't tested it out whether it works or it doesn't. So once you have like a user trait or a trait implemented for a given struct, then you can be able to use the methods therein. So in this case, I'm just going to, for example, comment out this line, and below it, I'm going to just type user1 dot print information. Because it's a function, I'm going to invoke it, and let's see what it does. So name, Dalmas, email, that's the email, username, that's the username, and that's the age. So that's how you do implement traits for structs. So for this case, this is not a okay. I'm going quite fast. So this is just a simple straight trait, but at some point you just want to make a trait that is reusable by other structs. So I'll just show an example, but I won't explain deeper. So I'll just refer you to Cairo book to go learn more about the so-called generics. That is another topic there. So that is generics. Generics will help you understand this further. So let's say we had these few things. We had a rectangle. So I'm just using an example from the Cairo book, but don't yeah, you will find it somewhere there. So we have a rectangle, we have a triangle, and we have a circle, and also we have a square. So you have been asked to create a simple Cairo program that will help calculate the perimeter of all those three, or of all those four shapes. So you can go ahead and sort of try to do like a direct calculate for each separately, but the best thing could be creating a single trait. For example, you can call this a trait maybe uh, geometry, and after you have this, you make it generic. You don't have to make it like to have a specific struct in it. Then in this trait, you are going to define the method or the methods that you want to uh, go through. So I'm going to add, for example, a method to calculate perimeter. So calculate perimeter. And this one will take in something like maybe self, then a snapshot. So I'm just using the term here, snapshot. What's a snapshot and what's a ref? I'll cover those ones in just a moment. So we have calculate perimeter for geometry. So what you're going to do is to implement geometry for each of these. And at the end, maybe here we know the value that will be returned, maybe it's a u that too. So we are just going to do exactly that. So just take the geometry and implement for each of these. And of course, this can be a rectangle. This struct, for example, rectangle, has its own values, maybe the height and the width. So W, and which is maybe a U that too, and width height U that too. So you might be having something like this. So you just implement for each of these, but from the same interface or from the same blueprint. That's the work of traits, and that's how they come together with structs. We'll be using them largely when we are doing our smart contracts. So I think we have covered this. So I'll just directly move to the next phase. That just before I move on, I have something like here to do with the art user. So, and I've been saying this is a snapshot. why are snapshots critical or useful in Cairo? So snapshot is just like taking a light picture of the entire structure of, or of a given value of a given variable, so that you can just use it for read-only purposes. You don't want everything. No, you only want it for read-only purposes. But what if you want to alter the value of that given, for example, in this case, the user struct? What can it have, or how can you achieve that one? So for this case, I'm going to do fn alter here, alter. Let's just use update name, and we want to use another value or another way for updating or for writing to that given struct. So here we are going to use something called the ref, and ref in full reference to self. And in this case, we are not going to pass in the other value here that we had, for example, at. So it's ref self user. Here we did just self at user, but here we have done ref self. So this one will allow you to update this given um, struct. And also we are also going, of course, going to pass in the new name. So new name, and we know our name is a byte array, so byte array type. So that's how you pass in parameters to a given function. Then after updating, let's see what will happen. So here we had user one, and we did print the information, and that's what we get for there. Okay, user MBL. Okay, we have not implemented all the functions, and this is the problem using this one. The problem, I'm missing update name function. So we'll need to write the update name function before we just proceed to do what we wanted to do. So here I'm going to implement or write the function logic, and I'm just going to say self dot name equals to the new name. So I think it was new name, like that. I'm going to reduce that space there. So if I run this, I believe it should run successfully. Yeah. So we have the first name here being Dalmas. So let's alter that one and see what we get at the end. So here I'm just going to go below the print statement and try to do user underscore one dot update name. And here I'm just going to change this one to Ogembo. And after that, I'm going to try to print user one dot print information. So let's see what will happen. So we have gotten our first error already here. Ref argument must be a mutable variable. So before there was some points here where we got an error with the mutability. So here at users, where we tried to push or append, insert a new user into our file 252 dict. So whenever you try to do this, remember, anything that needs change has to be prefixed with the mute keyword. So in this case, I have to go back to my user here and make sure I have the mute keyword there. So if I run now, you realize the first name was Dalmas, but now it has been updated to Ogembo. So that's where reference comes in and snapshot come in. Snapshot is just for read only, but reference is for a write only. That's another thing. So if you just want something, not write only, but you can use it to read, of course. Read and write. Snapshots for read only, and ref for both read and write. So that is a simple illustration for this. So next, somebody asked about the so-called ownership. So we just go through ownership a bit so that we see what it is and how can it affect you when writing your functions. So whenever we talk about ownership, okay, so in ownership it means a given block owns a given variable, owns a given thing. For you to be able to move it to the next block, you either borrow it or sort of try to find a way of making it appear to the other value. So for this case, I'm going to just try to illustrate that one using some examples. So I'll illustrate it down below here. And So let's write some code here. Let's say we have let you. I think I've done user, but anyway, I can do another user here. So let user two equals to. So I'm going to copy this user again. I don't think it will be necessary to just. So I'll just leave it like that. Or I don't have an informator. Okay, control save. So let me just update this one quickly. So maybe that one is dalmas.gamble. This something like that. And yep. So we have all that value updated. So that's another user, let's say. But now I want to use this user into various methods. So I'm going to write two methods here. And this method are going to have like the same thing too, the same thing or the same logic. So let me just write fn method one, and this one will take in user of type user, of course, and it will just do user.print information, nothing else. And also the same method or a similar method called method two will have something the same information. And down here, I just come and say method one. Then I call method one with user two. So if I do this and try to run this code, you realize it will just run shamaldas. That's the new print from the other, from method one that we have here. Let's try to do same for method two. So if I copy this or duplicate this line and I try to run it, then you realize we get an error saying, let's read through the error, at least we understand. Variable was previously moved. So we have something like this. The variable was previously moved. How did that happen? So how this works, Cairo, like Rust, is memory efficient. So whenever you, unlike JavaScript, actually JavaScript, you can just do like this and nothing will happen, or even Python. But Rust, Cairo, they are memory efficient, meaning whenever something is not needed in this scope. So what's a scope? A scope, for example, can be these curly braces, and usually that's a scope. In most cases, this is a scope. Whenever you see the curly braces, that means that's a scope. Even if we were to do something like write an if statement here, if true, so this is a scope that is that might not be accessible out here, but it's accessible only here. So I'll also illustrate that one in just a moment. So we have tried to use the same user in the two methods, but this method one, when it was called, it sort of moved. Now it owns the user into its own scope. So like the scope or ownership changed from this scope, from the main scope to the method one scope. So that's ownership. Like if anything moves from this scope to another one, like just moving not in the best way it should move, then it will just automatically like disappear from this scope to another one. So how do you solve something like this? So in Cairo, we do have another thing that you can add on your struct here. It's called copy. So copy will allow you to sort of just shallowly have your struct to be used, or do have here copy co-array byte array. So this is another problem you will be encountering such like things. So it's saying byte array does not implement copy, if I may just talk about it like that. So there are some attributes that you cannot use directly, and you have like something like byte array or other data types that do not implement copy. But I'm not going to go deep on how to solve such issues where a given attribute cannot be applicable to some data types. For now, I'm just going to stay safe and change everything to a file 252. So I'll have to sort of update my byte arrays like that. just to just go through it. Otherwise, there's a way of just dealing with such like uh, byte array, or byte array does not implement copy. And here I'm just going to convert this from double quotes to single quotes, like that. So if I do the okay, I do have here Ogembo still in double quotes. Where's that? Oh, here we go. So we'll have to sort of make sure I change everything down, otherwise we are about to have several problems here and there. So if I do that, you realize my program runs successfully and it does use both the two, or user 2 still is being used in both. What happens in this case, we have just taken a slight copy of the user, passed it here without moving it, then we also used it here. So that's ownership in simple words. But there's another one that I was to add on. For example, whenever I am in an if statement, let's say I have a variable here called let s, um, let var equals to new var. So we have like there a file 252. By default, anything that is not assigned a type, it's assigned file 252 in Cairo. I believe so, unless that one changed, but that's the thing. For Rust, it's just infers, but I think even this one, the compiler infers. So it will just infer and know, oh, this is a file 252. So you have like let var there, and here you can just sort of do something like print line my var, and I just do like var like this. So I can be able to do it like that successfully. But if I try to move out, let's see, I move this one out there and I try to do my var2 like that. Okay, didn't run this one. So what happened? I'm getting a different error that's saying var. Oh yeah, so it's saying identifier not found. So what does this mean? It means we don't have var in this outer scope. The outer scope we are talking about is the main function scope. So main does not own var, but this statement or this block here owns var. So that's the bit about ownership. Any other questions? Let me check. Yeah. So I believe I've tried to answer your question on ownership, or touch on ownership a bit. So since time is running, I think I'll go to the next scope. So we have done like the other portion that we didn't cover, that is finishing on the rest of the data types, which was critical. And for a short recap, we have done through the so-called tuples, dictionaries, arrays, structs, and also let me add this one. We have done traits, and also somebody here added ownership. Welcome. Yeah. Here we have ownership. And what did we cover here? We have also covered a few macros actually. We have covered the format macro, so I don't want to forget that one. We have also looked into the print line, how it works. And also we have looked into the okay, traits and implementations, so we can just do implementations. So that's how you do implementations. So if you want to go try it further, try to do generic types and all those things. And after that, what do we have next? I think we have also looked into the ref keyword and also the snapshots, ref and snapshots. So that's what we have covered so far. If there are any questions through those topics, or something that you feel like, okay, we need to look into that, drop it in the chat, then I'll go through it. So that's for the first portion of this. So the next portion will be quite short also. That will include doing a simple program in Cairo that utilizes most of these things. So let's try to build it. So I'll just close this VS Code. I'll just push that code. That's why I didn't delete anything. For whoever wants to try it out, they'll be able to find it and try it out. So what program are we going to do now? So we were to do a calculator, but I believe that one will be good for somebody to go try it. But let's just do that one. Scab new calculator. So that's how you initialize your new scab projects. Then clear, then cd calculator, then open it in VS Code. So there we are. So I have iterated through that also for those who didn't get that at first how we started our project, so that we can get here quickly. So I'll open my lib.cairo file and I'll close my sidebar, then delete everything, of course. Then I'll start doing some things here and we see how we can implement a simple calculator. This one is not not going to have everything, but it will have a few things. So it's the same thing that we had before. So I'm just going to do struct rectangle here, a rectangle, and this one is going to take a width u32 and a h of u32. Then after that, I'm going to have something to do with the square. So I'll just paste like that and change this one to square. And also I'll have a square, maybe a circle. Just a moment. Oh. So that's a circle, and what else? We can also have like a triangle here. Why not? So for circles, usually it's actually it can only be radius. So we can just do r square, width height, or base height. Rectangle, let's do base height. So that's what we have for our structs. And here I'm going to do a trait that's called geometry. And this will be a simple introduction to generics, in fact. So it will be taking in a t, then it will have a few methods. The first method is to calculate the perimeter, or so I'll just write calculate perimeter, and it's going to take a snapshot of self, so at t, and then it will just sort of do the calculation. Then after the perimeter, we'll also have area. So let's just write area. And also we'll have another method here called print. I'll call it print. Okay, print cells. And for a square, somebody might ask, hey, doesn't this need to be SS? Okay, side by side, but I believe let's leave it at that. But there's no difference between it and the rectangle, so that's the thing. And also to help us avoid the drop problems, so I'm also going to derive the drop attribute here for each of these structs. And in fact, just to avoid the other issue, if it might come across, just have the copy there. So I'm going to have them like that and like that. So we have a trait here. So we are going to just implement geometry. So I'm just going to do rectangle geometry implementation. And the t that we had here now is going to be rectangle. Then here we are going to implement the three methods that we have here. So I'm going to copy them, paste them there. And usually once you have done the copying, you just delete the commas, the semicolons, and replace them with curly braces for you to get started. So the first method is called print, and the print is just going to print this rectangle is this by side. So I'm just going to do print line, this rectangle is so dollar sign. So I need to do x that. That's it. So I just need to do self dot. And actually remember, whenever you change your t's or you pass in the exact type, also remember to change it here to avoid any other issue that might arise because you are now implementing it for a given struct. So self dot w and self dot h. I think that was the thing. Calculate perimeter. We know the perimeter of a rectangle is sort of a print line. I've started with the print line, but that's not the thing. Let perimeter equals to, we know it's 2LW. Oh, okay, that was LW, not WH. Length with it, not, yeah, I think let me just avoid confusing things here. Let's just have the exact values. Length with it, this should be SS, but let remain WH. So we have changed that one, LW. So the length is the L and the W is with it. Okay, yeah. So here we are just going to do 2 into, so 2 of course times, then it should be self dot L plus self dot W. And if I might miss this, guys, kindly drop the link, drop the comments there. I can't clearly see the screen, so I'm not sure whether it's my network, but let me sort of zoom out and zoom in again. Okay, not that one. Here I'll just zoom out like that and zoom in again. You can confirm whether it's clear to you. Pencrypts technologies. Okay, so we have it here. Calculate the perimeter. We have the perimeter, so 2 times. Not clear yet. Okay, I think I'll just drop the share and reshare again. That will help. So I think it's dropped. Then I'll share again the entire screen. Okay, confirm whether you see it. You can also increase your video quality. I'm not sure whether I can because that one is still like wait, where am I? I should be in this window. I should be in a different window. Okay, that's nice. So I have zoomed in further. So we were doing the perimeter here, and we can say the rectangle has a perimeter of, and here we are just going to do the thing that we do good. We just write their perimeter and do our curly braces there. And finally, it's the area. So for the area, we can do similar thing, I believe. So let's just copy this, paste it here, and write here area. Change this one from this. Delete these outer brackets. The rectangle has an area of area like that. So we have this for our rectangle. So let's try run or use this in our method here. So const, I'm talking about constants here. Constants will be introduced whenever we touch the smart contracts. So here I'm going to write let rect equals to a new rectangle like that, and it's going to have a length of 4 and a width of 2. That's our rectangle. First, let's try to do rect dot print. We see what happens, and we see whether we are in the. So we have rect dot print has an implementation in context. Trait not found. Oh, I think I missed this portion here. I didn't do the right implementation of a given trait somewhere there. So I think I'll need to go back and rectify that correctly. I don't see any other errors except that one. Okay. Give me a moment. Okay, just taken a glass of water here. So let's go back and rectify our work. So as when doing your implementations, remember to do hit them correctly. So here we need to do of geometry because it's geometry that we are implementing for rectangle. So that's what I missed here, I believe. So let's see again. So here we have self.l, self.w, trait 2 times, okay, mismatch the type call you that 2 cannot be created from a numeric literal. 2 cannot be created from numeric literal. Okay, let's just debug them slowly. So we have here the perimeter where it's saying it cannot be created from a numeric literal. So we know this one is is it a U32? Right here, it's a U32. So what we can do here is to make sure that we cast this like that. Okay, U32. Let's see whether it works. And also here we have a problem. It's saying core integer U32 found, core integer found at. So we have something here called at. Somebody might ask, what is this? So we talked about this and we said snapshots are critical when doing them for read-only purposes. But now we are having something else that is giving us a few headaches here. The so-called at core integer U32. So you might come across this one when writing your contracts. Let me just paste it here. So what this means is that the error that we are having right now is saying this is not equal to this. Where is my equal signs? Yeah, it's not equal to this. That's the error we are having right now. So you can't like just come here and say take at core U32 and multiply it with the U32. So it will just say no, not today, sir. So what happens here, we've been saying about there's a term that I used earlier called unboxing, unwrapping, and all those things. And you had seen the term unwrapping when we were doing type conversion, where we could convert a U16 to a U32 to a U32 to a U64, etc., using the dot try into and then dot unwrap. So it's similar thing that's required here. You just need to move remove the at sign here. And how do you achieve that one? So there's a way of achieving it. It's by using a star or asterisk. So I'm going to add an asterisk there. So this is like um, removing the so-called oh, I didn't delete my line here, removing the snapshot value of it and getting not the real value, the underlying value. So it's like now getting the not the copied value, but rather like a copied value that it's not, that does not look like a copied value. So I'll just delete this line. And you do realize from the error that I've already gotten here, it's having the same problem, the at core integer u that too. So you need to remove the snapshot by using the star or the asterisk. So I'll come here and do the same like that. So if I run this one, if it runs successfully, this rectangle is 4 by 2. That's what we have. So let's run the rest of the methods and see whether they work. So rect dot, we had calculate perimeter first. So let's see what we get. There we go. So the perimeter of this, the rectangle has a perimeter of 12. So I need to change not the to this. I think it will be good like that. And then finally, let's do the rect dot calculate area. And if I do this now, we have that one. I think I saved, and we are getting the rectangle has an area of 6. Can that be true? No, it can't be true because it should be a star here, like for multiplication, of course. Yeah, the rectangle has an area of 8. So that's how you do generics, and that's how you write like simple programs in Cairo. Now you move this simple code to an advanced code. That's what you do with your smart contract. So add all these things together and then finally create something large, something huge that everybody will enjoy looking and interacting with in your front end. That's creating a D app. We'll also reach the D app development portion of things. But for now, uh, so that's a simple implementation for the rectangle. I'll just look according to my time I have. So I'll just try use the 3 minutes and do the same implementation for another geometry object, and we'll have covered. So I'll just do for square because it has like similar values. So the rest, I believe you can handle them. So that's how you use the same trait for different structs using the so-called so control D paste. So the square perimeter, this should be WH, I think, and also here should be W self.W self.H, and here should be self.W self.H. So that's generics in short term. We could have done a shopping cart, but that could take more time. So try that one for your assignment and see what you get. So let square equals to square, and this one will need a W which is a 20, and H which is 20. I'm only using small numbers, but for this let's just use large numbers and see what we get. Maybe it will inform the next comment. Print, then let me just copy these two boys here, paste them here, and then control D. No, only one to the 2, and do actually the 3 square here like that, and I try to run this one whether it works. So we see the square, this square is 20 by 20, this square has a perimeter of 80, and this square has an area of 400. We are like today, we are not seeing hex values here. Quite an improvement in Cairo code. Now it's now becoming developer friendly fully. Before you could also only see, like for example, 20x2. If it's a 10, it has 120xa. If it's a 50, something that you don't even see coming. So that's for generics. Uh, I'll go back up and try to do something. So I'm going to get rid of the copy uh, attributes and try to run my program. It still works. So the reason as to why it still works is because we are only getting or reading something's called like we are only taking snapshots. But at some point, if you don't have the copy trait, then be sure to have problems at some point. So if you get an error like something is not copied, does not implement copy, does not implement drop, remember to add or derive the macros there. So I'll proceed to the next portion unless there's a question. So I'll just going to check, but a good example, be very careful with uh, okay, I think I'll try reading that one out. We see it. C and P. C and P, but a good. Maybe kindly illustrate JD. Okay, please. You have what? Okay, I don't get what you said there. Maybe it will come in later, but let me proceed. Uh, I'll go to my VS Code. So that's just a short example of a calculator application. Just take your time, implement for the rest, do this map that we have done a bit of it here, and the traits will be very useful in the next section. If there is any question, kindly drop it in the chat. I'll be able to hope so. I'll be able to answer it. So let me go back to my slides and see where we are at for now. So I'll just do present. So so this like when we came back here to just look at a few things. Uh, yeah. So I'll just walk forward a bit. Variables. Working with the storage. This is another one. Arrays and mappings. We have done this arrays and mappings. We can call them for now felt 252 dicts. But there's another mapping that we'll cover when we'll be starting working on our smart contract. So yeah, we have done the complex data structures and all those. So there's another thing that I'd like to cover here: modularity, security, gas optimization, upgradability, and documentation. Oh, actually, this one is under contract logic. So I'll cover this one in the contract itself. That includes modularity, but we have seen how modules work. If you do recall, when we started off, we did look at a simple module that was the test module that was decorated by the CFG test attribute. So that's modularity. In terms of security, we'll cover it in the contract logic when we'll now start writing our contract, and also upgradability, of course, in the contract. In terms of gas optimization, this I think if you have don't the first rule, don't store anything in memory that you are not using, or read anything that you're not using, otherwise it will be a waste of memory and hence increased gas fees and all those things. So that's for a simple cairo program. If time would have allowed, we would have covered something more complex like a shopping cart or even a user registration stuff, but let's leave it at this point. We go to the next section of covering cairo smart contracts or Starknet smart contracts per se. So just a moment. So let me have a cup of water, then we'll continue. So take a break of 2 minutes and we'll get back at exactly 1941. Hello again. So let's go to the next portion of this of today's class, that is covering smart contracts. And in this case, what we are going to do is the simple smart contract. We deploy and interact with it, then update it. Then the next class will be another deep dive into smart contracts and a front end. So the next class will be covering like now creating a front end for a given smart contract. And also we'll take that one further down and look at the common smart contract examples, including how you can create your own ERC20 and even maybe an ERC 721 as examples, because those are the common things that one will want to know or will need to know in order for them to develop nice D apps. Because D apps just rotate around uh, ERC20, ERC721s in most cases. That is D apps that are user facing, because unless it's a game, it has to have an ERC20. Even if it's a game, still there's an ERC20. And if in a game, ERC721's very critical. So what is the next step? So let's do a simple contract and we interact with it and see how these things now come into play together. So I'll also close this one, and for the calculator app also I'll try have it somewhere for you to get it. So clear on the CD. I'll just go back a bit, then and I'm going to write now a simple contract. How do we initialize contracts? We are starting our packages cairo programs using scab new command, but now we are going to use another tool. This is one of the tools that we had installed in the second session, that is Starknet Foundry. So Starknet Foundry comes with two tools at hand. The first one is a SendForge and another one is a SendCast. Both of them have different use cases, and if I may go through them quickly, SendForge helps us to initialize new contracts and also test out our contracts, while SendCast helps us to test out our contract or interact with the blockchain using our terminal. So for this case, you can now, for example, use a SendCast to interact with the mainnet or Sepolia or the GUI is been deprecated, so let's leave it out. So let's create a simple contract, and so I'm using the SNForge tool, SNForge, and now command from Starknet Foundry SNForge something. So I'm going to first start by showing you how to learn quickly how to use these tools. So we saw when we started off with Cityscab, Scab. I illustrated with the Scab help how you can add more or add libraries to your contract, to your Cairo program. And Scab is also useful here. Also, you can use it to do the same. And also, it's shown you other functions that Scab has, including Scab FMT. We didn't use Scab FMT, but Scab FMT helps you to format your Cairo code. Sometimes your VS Code might say, no, I'm not going to do IntelliSense for you today. I'm just going to relax. So just use a Scab FMT. So I'll just illustrate that one as we go on. But for now, let's just see SNForge what it has. And actually, it comes with some docs here. So if you miss something, SNForge help, you have a lot of docs from Starknet Foundry, Cairo book, Starknet documentation, and Scab documentation. You see they sort of have highlighted all this here. So we have test, init, clean cache, and help. Help is what we have used. Init is what we are going to use or start a new Forge project or a smart contract per se in this case, and the clean cache to clean the Forge cache directory. Test to run the tests. So let's just do that one. So clear SNForge init, and the contract name is going to be, let's call it the name which it's being called, Hello Starknet, and that's invalid package name Hello Starknet. Yeah, that's another thing. They don't like camel case, so remember to maybe keep it to at snake case. Otherwise, init hello, need to delete that one and write correctly Starknet like that. So it's going to sort of initialize a new Starknet project, and it will just sort of pull from their repo there, and they have done great work by giving you like the default setup. But for the default setup, I'll explain everything. So I'm going to cd into that project, then open it in VS Code like that. So we are in VS Code again. And for this case, now we are here for the main deal of the day, covering smart contracts. This will be an introduction because of time, but bear with me, we might extend with a few more 5-10 minutes to cover the rest of the things. Scab.toml has more things now, and you realize now our Scab.toml is more styled. Like now, styling has decided to wake up from where it was relaxing. Um, the only difference here is when you are just writing Cairo program, you will need to set up VS Code to handle that one separately. But when you are writing Cairo or Starknet smart contract, now the Cairo syntax and the Cairo 1.0 extension will just gladly come to help you. But for Cairo programs, just pure Cairo programs, not contracts, just some dust a bit, but not that heavy. With the help of Cairo book, you will go through. So same package name, that's the name of your project, of course, but the name of your package, or yeah. Then the dependencies here for now, we have Starknet. As I said, you can add Alexandria format. And also we have another dev dependency called the SNForge standard. So this SNForge standard will provide the tools required for you to test the contract. And also, why will you write tests using a SNForge, not the Starknet core testing library? The main reason here is because a SNForge standard is more easier to use, and also it will allow you to do advanced things easily, like you can fork Sepolia and try to use it when you are testing your contract. For example, in transferring tokens around, it will help you in doing that. Then next we have something called the target Starknet contract, target.starknet contract. So this will define what you are going to build at the end of the day. So for this case, it's just going to build the Sierra file, but something that will also cover is the Casim file. And for those who were here between the first and second class, we talked deeper how these things come into play together, or these two things, yeah, Sierra and Casim. And then finally, we have scripts, and only we have here test. Then after that, our good scab lock, the .git, now it is even ignoring the send foundry cache because that one is not supposed to be uploaded anywhere. And finally, we have the tests. So that's how tests are written. And as I said, if you just have your tests somewhere else, usually they should be under the test folder. Just name them, okay, in any file, of course, but not just test underscore no, any file. Decorate them with this attribute hash test there, and they will just work correctly. So this is the initial step for writing tests. And let's just go to the contract and we'll go deeper into it. So this one, I believe it's bit of styled a bit, so we can be able to see more things. So if you look at this simple contract, starting from line 8, or where our contract starts, we have this hash Starknet contract. So this is how you will be initializing or telling uh, the compiler, this is my contract, or this one of my contracts. In fact, you can write several contracts in the same setup, provided you just decorate them with the contract. The only catch, you have to deploy them separately. Uh, so this is what we have: Starknet contract, then mod hello Starknet. Those who are coming from the Solidity background, you'll also know that you start your contract by writing the contract name. This is your contract name. Hello Starknet is our contract name. Then after that, we have our first struct here. It's called storage. This storage struct is decorated with this attribute storage. So this storage identifies this struct to be used, or it makes this struct to store user or contract data. If you get rid of this storage, then this struct will be sort of just like a normal struct. You don't just want a normal struct, you want a struct that stores data in your contract. So if you miss that line 10, this hash storage, then your storage won't work. Another thing to take care of, the storage struct starts with a capital S. That's the thing, and it has to be named storage. You cannot have like something else here like storage one for something else. No, it has to be called storage. The weight is storage. Then the rest of the story here, just write the story that you have. That includes what variables do you want to store. So here, for example, I'm going to store users, and I said I'm going to introduce another map method called now it's called the not now, but it's called a legacy map. But when we were looking at when we were developing the on the Cairo programs, we used a felt 252 dict. For this case, we are using a legacy map. By default, felt 252 dicts cannot be stored on Cairo contracts. So the replacement for that one, and a better replacement, is called a legacy map. And a legacy map can only work under this module. Let me just leave it there. It can only work under your contract. It can't work outside. For example, you can't have another struct out here, maybe a user struct, and I try to use the legacy map out here. So that one doesn't work like that. You can't use a legacy map out there. It can only be used in the Starknet contract. So that's the legacy map, and here we can do something like a contract address, and maybe now our user. So our user can stay out here, there's no harm, but more things, yeah. So our user can still stay there, but we'll cover more about our user later on. For now, let me just delete it and keep things simple the way they are. So I'll delete our legacy map here. So we have other structs that are critical that we'll be using. For example, I have already shown you one. It's called, okay, storage is one of them. Another one is the contract address. So contract address will help you like store the contract addresses now. Contract address can store anything to do with the contract address itself and the user's account wallets. But we don't rush. We'll cover these ones. So come back for the next class. Otherwise, you'll be missing something large. Uh, so that's our struct. This is the main struct that stores your data. There's something that I haven't covered completely. It's called components, but I believe that one take your time to learn through because they also need like some time for one to cover them. So components can help you like now sub or use like create your reusable components that you can be able to use in different uh, projects. So Starknet components, take a look into them. They are under Cairo book, I believe. You will find them there. Next, we have the first implementation of a given trait out here. So we'll start from the trait, then come to the implementation down here. I believe that will go flow well. So at first we have our trait here. It's called iHello Starknet. Then it has the T contract state. This is a generic and it has to be called T contract state, if I'm not wrong. So we covered the generics in the last like few, uh, that's there between 1 hour, 30 minutes, there around. So those generics we covered, this where they're being used now fully, except in a lightweight manner that you will understand as a developer, not like very, very complex generic stuff. So this trait, it has also been given this pub keyword, and the pub keyword makes it publicly available. Without the pub keyword, then this one might not be exported in your Sierra file or in your ABI. And also, it might give you several problems. Have it if you don't want problems. It is decorated with the Starknet interface attribute. So I was interjecting a traits interfaces when we were doing the traits, but now whenever you write your trait in Starknet, it has to be decorated with this thing here, hash Starknet interface. And you don't have to import anything. They are sort of pre-built into it, so you'll have them like they're up and running without issues. Same as the Starknet contract. Provided you have added Starknet into your dependencies. If you don't have Starknet in your dependencies, be sure to have some problems. Next, our trait here, I've said it's a generic trait. It can be implemented for any struct, and for this case, we are implementing it for contract state. We are not implementing it for storage. That's another thing you do need to recall, but I'll explain the implementation in a bit, in a moment. So we pass in here a T contract state generic, and the increase balance takes ref self T contract state and the amount that we are going to increase with. As I said, if you do something like this, it allows you to update the underlying struct. And for this case, we are updating the contract state. That's the underlying storage. That's what we are going to update here. And the get balance, since it's only getting or reading the balance of the contract, we are using snapshots. We don't really need the write permissions. We only need the read permission. So snapshots. Don't use refs where you are not supposed to. Either don't use snapshots where you are not supposed to. And for our snapshot here is going to return a file 252 whenever it's being called. Flowing down to the implementation of our trait here or our interface. Now I'll be using the term interface. So this interface has been implemented for contract state. And remember, you can have several interfaces, then implement them the same way this one has been implemented. So maybe you might have an interface for users, an interface for tokens, an interface for projects, an interface for something. Just implement it for Hello contract state. So that's how it goes. contract state, not hello Starknet. So contract state here now is no longer, here we only had like it's generic, but here now we have the real thing. Contract state is what we are going to update. And as I said, the other time we only updated a struct. So take this as a struct that you're updating, except this patches your result into the chain. It stores them on chain. So here, our implementation here, we have like, I'll get to this line, we have ABI embed v0. So what does this mean? If I get rid of this line, it means I'm not going to export these functions in my Sierra file. For those familiar with the contract development, you are not exporting this one to the ABI. Meaning, if you try to look at your ABI, you won't see the increase balance method or the get balance method. You'll only be seeing, like, for this case, if we're just like build this, we'll only be seeing blank methods, nothing else. Like, there are no methods because we have not done this. So this one will help you export or show those values to the uh, external world. That is, export them to Sierra file, and anybody can access them through the block explorer, like StackScan, Voyager, block view. Yeah, that's the work of a BI embed v0 attribute. So make sure you have it there. Otherwise, your methods won't be exported. Then we have the function implementation. Oh, actually, I've jammed. So in BL, Hello Starknet, that's the name of the implementation of. We are now implementing for the interface, and we are passing the contract state. Why have we used the super here? So this part of modularization. So this is a different module than the outer scope, and this is like the scope that we talked about a little bit. So the super will sort of pull this value from the outer scope and bring it into the inner scope. So for this case, since they are on the same file, that's why, and this is a different module, this can be considered a different module. You have to sort of use super in order to import it from the outer scope to the inner scope, then implement it for contract state. And here we are just going to write the contract logic. The first method is increase balance. I said it takes ref self, meaning we can update the contract state and the amount that we want to update with. So what we do, self.balance.write, and this is the only method that you're going to use to write to the contract. So if you have something like this, you just need to self.balance is the key, just write it whatever you want to write there. It has to be a felt 252 that you are writing there. When we do complex keys using legacy maps, you just write your complex legacy map key in a tuple format. That's what's allowed. Also, you can use structs as keys, but personally, I do not advise it because you might lose the keys. You might miss to construct the key easily. So legacy maps, you can use legacy maps and the tuples. So I can just quickly illustrate that one. So let's say we have users here, and I say legacy map like this, and not like that. So I say I want to track users, and maybe the user. So maybe I track the contract address, and also I track the user ID there. So this can make a key, and this key, if you are good enough, you can be able to construct it. Not just good. So, okay, this key is sort of complex. I don't use it personally because I don't know the contract address and I don't know this U256 where I will get them. And at the same time, you want to avoid storing other information in a given database outside the blockchain, because somebody can go update this key. Then whenever you are trying to read for a given contract address, you find you are receiving a different use or a different value. Usually use something that you can be able to construct, like a 2U256. This one you can be able to construct, but that is for the fancy case. Let's just proceed. So that's how you write. Then what about reading? Reading, you know the key, self.balance is the key, then .read. And so because this is not a legacy map, for legacy map, there's other things that you need to do in order to read the value correctly, but This one is quite straight. You only need to read the balance and it will just return that. And so that is it. So I think, I don't know whether I can be able to do that one, self.users.read. Oh, and actually, if it's a legacy map, you can also pass the key here. For that case, we had a key. Maybe you can read the user from group one, user one. So that's a key. You can use a key to read if there is one for legacy maps. But if it's for just values like balance, maybe you have like the private key or the owner, usually just do .owner.read and that is it. So I'll just close this one. I think time's running, so I'll get back to the tests a bit and illustrate something there and run off. So in the test, we have already been, Starknet Foundry has done a good work, giving us the basis of tests that we can be able to continue to use from here. So you can reproduce any other tests based on this example given here. And here, something I missed to talk about is pattern matching, but just go through the Cairo book and you'll understand the importance of pattern matching, the things of recoverable and unrecoverable errors with the panic. And yeah, so this one, I think I'll explain how these dispatchers work or what dispatchers are in the next class. For now, let's just deploy the contract and interact with it quickly before time runs out. So once you have written your contract and finished, the first thing you want to do, always write test for your contract. So SNForge test. So this will test your contract and you don't need to have Starknet DevNet up and running. Now, our contract is correct or at least test pass. So the next thing that we need to do is run Starknet DevNet and proceed with the deployment procedure. So I'll walk right into that and any questions you can post. So here I'm going to type in the command to run Starknet DevNet. So just run Starknet DevNet like that. And I have Starknet DevNet up and running. So I'm just going to sort of do, I don't know why this thing is not increasing the font. Oh, got it. Control Shift Plus, yeah. So whenever you run Starknet DevNet, you'll get or you'll receive 10 different accounts pre-funded with about 1,000 ETH. Of course, test it for your work for local development. So, and also it will provide a few more things, a pre-deployed UDC. So what's a UDC? A UDC is a universal deployer contract. I don't think if I'm going to explain that one further because it's not also like a direct thing. But if you are on Starknet, if you search for Starknet.js, starknetjs.com, you'll be able to learn more about UDCs or what this UDC is and what a pre-deployed fee token is. So these are the pre-deployed fee tokens, ETH and Stack, and also we have a class hash that I think generated these accounts here. And each actually the pre-deployed accounts using the class hash here. We have a class hash here. If time allows, you can be able to learn more about how to use the same class hash to create your own accounts. But for now, let's proceed with what we want to do. That's deploying our contract. So each account that you are given here is given an account address, a private key, and a public key. So what's the next possible thing that you want to do when deploying your contract? So whenever you are deploying your contract, the first thing you want to do is building your contract. So scab build. And actually, there's another command given by scab called scab clean. So scab clean is going to just remove all the cache and any other build file. So this will allow you to sort of rebuild from a fresh, like no other files being overwritten. They have already been deleted. Then you do run scab build. So scab has built our project or our contract. Then the next thing that you want to do is create accounts to interact or deploy your contract. So since we have already have the accounts here, we just need to move them to a place where we can now use the private key and the public key to sign the transaction. So that's the next thing that we are going to do. And that one is also kind of easy, but I'll explain it as we go on. So scab accounts. So we are just going to use not scab. I'm sorry for that. It's Zencast accounts command, and here I'm going to use the help flag to see what happens. Okay, yeah, it's a Zencast account, not accounts. Okay, yeah. So here I have done a Zencast account, and this is your secret of getting used to this uh, tools. Use help command quickly as much as you can. Otherwise, you'll be having some issues dealing with some errors that might arise. So we have a Zencast account has a add, create, deploy, delete, and help. Now I'm only going to use the account to add an account to the accounts file. So Zencast account add. But before you do a Zencast account add, a Zencast itself requires something for that command to run successfully, and it's called a URL of your local RPC endpoint, so that it can be able to be available for it. So I'm just going to add that one. So clear. So Zencast accounts add Zencast minus u http localhost port 5050 /rpc, or you can just leave it at local 5050. And where do I get this RPC endpoint from? If you open your Starknet DevNet, when you run it, it will show you where it's running. So for this case, it's at localhost port 5050. So that's what I have passed in here. Then I'm going to do account add, and the account add has a few more, has things that it requires. So I'm just going to run it separately here to see the required things. So Zencast account add -- help. So it will require one to pass in the name of the account, the address, the type of the account. If you know the type of the account, by default it's Open Zeppelin. You don't need to pass in the class hash, and also you need to pass in the private key and the public key, and also whether you want this account to be recorded in your sendfoundry.toml file. So that's the next file that I'm going to show you. I'll just walk right here. So account add, the name here we are going to give it is account 1, and the public key. So let's see what's required again. So we have passed in the name using this one. Then what's required is the address -a. So pass in the address, and the address, I'm going to pick the address of the first account. So I'll come back here, scroll up, account address, pick that one, and paste it there. After the address, let's see what does it require next. It requires us to pass in the private key and also the public key. So that's what we're going to type in. So -- private -key, and the private key will also obtain it from the same account that we copied from. So private key is here, just paste it here. And finally we do the public key. I think that's not public key. So we also copy the public key from here and pass it there. Copy, paste. And then finally, we also need to say add profile. And for this case, I'm just going to say the profile we are going to add is account 1 profile. What does the last flag do? Add profile will add it to a file that will be created here shortly called sendfoundry.toml file. I'm having an issue here. I think I need to see what the issue is. Okay, it says the account type is required. So I'm just going to come back here and try to type. I think I can do OZ. Let's see the account types we have here. We have Open Zeppelin, Agent Account Implementation, and Bravo. So I'll do Open Zeppelin. So it's going to say account 1 created and profile account 1 successfully added to snfoundry.toml file. So what's a snfoundry.toml file? This is another file created by SNcast to help you track the different accounts that you have already created. By default, whenever you create an account, it will be added to the Open Zeppelin account.json file. This one is quite familiar for those coming from Ethereum development and who did use this Open Zeppelin account when signing their transactions. And also, it will secure your private keys and public keys so that they are not found in your project folder. So even if you were to do a mistake and push sendfoundry.toml onto GitHub, somebody cannot be able to see your private keys. That's another advantage of using Starknet Foundry when doing your interaction with the contract, either on mainnet, Spolio, or on DevNet. So that's how you add an account to Open Zeppelin accounts. And now we'll be using this account to do the rest of the things that we want to do. And for this case, we want to make this account the default account before I forget. So to make an account default, here we have sncast.account1. To make it default, you only need to change sncast.default like that. Now remove sncast.account1 to sncast.default. That one will make it the default account that will do everything that you want it to do. So I'll open my lib.cairo. We have our contract here called Hello Starknet, and here I'm going to do so what I'm going to do here is just do a sendcast. So let me just pull the help command here. And here we are we have the declare command and the deploy command. We are going to use these 4 commands right now. So let's use the first one, that's the declare command. So before you deploy your contracts on Starknet, you need to declare them so that they will be known that, okay, so declaration, it's like you are uploading the source code, the custom file somewhere so that it can be stored there for anybody to sort of fork and use. So if you have a class hash of a declared contract, you can deploy that class hash with your own rules. That's the advantage given by Starknet. So the same class hash can be used to deploy several other projects or other contracts. For example, an ERC20, if you go to sit and Raggable or Raggable, I don't know, in Starknet, they are using the same underlying contract. The only thing that they want or they're using is the same class hash, but the token name, the token symbol, the total supply is totally up to you to set. So it's the same class hash, it's like just a fork. So let's create our class hash here. So sncast declare -- help. I'm also going to pull the help command again. I like doing this one to help me see what I need to pass in for my command to run successfully. So sncast declare -c is the contract name, and here we are going to pass hello Starknet. I believe that's what we have here in line 9. Once we do that, we just hit enter, and it's going to do its stuff, and it will give us back the class hash and the transaction hash. There's something that you might notice if you try to redeclare this contract again. You will notice it won't come back with the transaction hash because it's already declared. There won't be a transaction hash. So if you by chance try to declare an already declared contract and it doesn't give you the transaction hash, just know it's already declared. Is it? Yeah, I think it's the transaction hash. So once you do this, don't clear your terminal because we'll need this class hash in the next command. And then the next command is sncast. So I'm going to just clear this one. It's a sncast deploy --help. In deployment, it will only require you to pass in the class hash and any other constructor called data. There are other properties here, but these 2 are the most critical if there's a constructor. I'll explain what a constructor is in the next class most probably. So it only needs the class hash. So you can copy this and use that one in your next command. So sncast deploy, and here I'm going to deploy and pass in the class hash. Actually, I needed to, this is not even the class hash itself. I need to pass in the flag dash dash class hash. The short one is dash g. Then I need to paste this class hash there. So copy that one, paste. So it will deploy and it will give you back a contract address. So we have a contract address that we can use for the next or for the rest of the things that we want to do that's interacting with our contract. So I'm going to paste it here for now, like that. That's our contract address. So I'm going to, so that I can clear my terminal, it becomes clean. We saw two methods in our contract. The first one was increase balance and the other one was get balance. So we'll start by doing the get balance method, then to increase balance method. So here we are going to use another command, sncast city invoke call. So sncast call is to usually for reading, its call is usually for reading purposes. So I'm also going to get the help from it. So here we are being asked to pass in the contract address and also the function name and any call data. So how do we do this one? So it's just simply sncast call dash a, that's the contract address. So we have our contract address here. So if we may copy, where did I paste it? Here, and I paste it here. And the next, it's asking us to pass the function name, so dash f, and the method we are going to call is get balance. If I'm not wrong, from the lib.cairo file, yeah, get balance. There are no parameters like that we are supposed to pass, the so-called call data. So by default, the self, like any other language, it's not counted as a parameter that you need to pass in. So you don't need to pass in. That's why we don't need to pass it in here. So if you had any call data, you could have done call data like that, and actually it's called data like that, or dash c and passed it in. But we'll use that one in the next command. So here we get back 0x0, and as I said, this way it might look weird, but just not that tough, because this is just an hexadecimal. So it will return it in an array, because this is called a row result. So if you have interacted with Voyager bits, I'll just illustrate that one in a moment in Voyager after doing the next command. So 0x0 is what we have. But if you go to the so-called hex to maybe decimal and pass in your 0x0, you will realize that's just 0. So let's invoke our contractual right to our contract. So what we are going to do, it's the same thing, but the method here is called increase balance. And what we are going to do is not a sncast call, but rather a sncast invoke, like that. And this increase balance requires some call data. So I'm going to do dash c, and I'm going to increase the balance by 2. What if you had several parameters? Just do a comma there and pass in your parameters. I believe so. We'll see that one. So once I do that one, it will return back a transaction hash. That's what happens with the so-called write functions. Write functions do not return anything. Usually, they only return transaction hash. What you do with your transaction hash, pick it and listen for that given transaction. I'll be able to show you on the front end. So there's a method that's called account or provider.wait for transaction. Then you pass in this transaction hash so that you can be able to get any emitted events, so you can record them off chain where you want to store them. So that's another way of sending data off chain, instead of writing like a function, maybe running on the cloud, listening for all those events. Just do those events whenever somebody finishes them from your contract on the front end. But that one is a catch, because if somebody interacts with your contract from the block explorer, then you won't be able to record that event. That's why you have to have your cloud function running. So that's for invoke. Now we want to redo the call command again. We see the balance. you realize it's now 0x2. If we check 0x2 is just 2. Now, if we now again increase the balance by now, I'm going to increase this one by 10. So we have increased it by 10. Now we expect 12. Let's see what we get. We get 0xc. What is 0xc? So that's where rapid tables comes into play. But for your front end, you are not going to come to rapid tables for you to convert it. There are methods of achieving that one. And I believe some of you here already you know how to get to it. So I have 0xc there. If I click that one, convert, now I get 12. Now, if I try to increment the balance again by 10, now we expect 0x16, which is now the 22 value 22. So it means we are able to write to our contract and read from it correctly. So that's the explanation of today's, or that was the last part of today's session. Don't know whether there are any other questions, but while waiting for them, just a quick recap what we have done in this last section. So in this last section, we initialized our project using SNForge, and it gave us like a minimal template Hello Starknet contract that we read through. We understood that traits are interfaces, and also for us to initialize our contracts, they have to be decorated with the Starknet contract attribute. And after that, our storage struct, the main struct, should be decorated with the storage attribute to a storage attribute. And if you want to expose your functions, remember to add the hash API embed v0 attribute. Then finally, also on the tests, we use the SNForge test or SNForge to test out our contract. Oh, not really finally. And now finally, we use the SNCast to declare, deploy, and interact with our contract. That is both reading and writing into the contract. That's it from my side, unless somebody has something to ask. Okay, then if there are no questions, then I believe, but keep having the questions coming. And for your assignment, for those who are here, you are going to write the calculator application, complete it, and also maybe do another Kairos program, and also try to initialize a new project, deploy it, and interact with it. So those are like 3 of those things. Till Monday next week, it'll be good to go. So I'll just write them here for anybody who wants to know about them. So that is niche the calculator app program. Try deploying Hello Starknet contract. So that's it from me. I don't really have much to add on. Yeah. So I think I'll call upon Obed if he is up to close up. Obed, can you hear me? Okay, so seems like Obed is not maybe around. So that's what we have covered today, and I'm sorry for taking 23 of your minutes. It's because we had like a lot in our plate to eat, but finally we have been able to clear the plate up as we prepare our stomachs for the next portion. So prep your brains and test out everything that we have done. Then we'll be good to go for the next class. So for the next class, as I said, we'll be covering now an in-depth look into the smart contracts, write our own smart contract, not the Hello Starknet smart contract, and also do front-end stuff. That is now integrate our contract to the front end. And I believe we are together. Thanks for staying up to this time, and I welcome you to the next session. That's next week, Monday. Thank you. Till then, adios.